Okay, we're doing a probability problem here. We have the standard deviation of the lifespan of a certain brand of LED light bulbs is 25 months. So that is a population standard deviation given to us, 25. The quality control department at this company takes a random sample of 80 LED light bulbs. So that's going to give us a sample size of 80. Finds the mean lifespan of the sample. So that's X bar. Mean of our sample is 144 months. What is the probability that the sample mean is within 1 month of the mean of all light bulbs produced by the company? Round to 4 decimal places. Okay, so what this is asking is the probability within 1 month. So that means 1 month of 144. So that would be a probability between 143, because we would subtract 1 month, and 145, because we would add 1 month. Okay, so that's what we're looking for here. So in order to do that, we need to use this formula. We need to normalize these scores, put them on the normal curve. So we want to use the z-score formula where we have x minus x bar over the standard deviation of x bar. So we have x bar, we have our x's. We need to get that standard deviation of x bar, standard deviation of my sample, which is given to me as the standard deviation of the population over the square root of our sample size. So that is 25 over the square root of 80. So let's go ahead and get that value. So we have 25 divided by the square root of 80. And that will give us, we'll go 5 decimal places out. We don't like rounding too much in between here. So 2.79508. Okay, and there we go. So let's go ahead and find the z-scores for these values. So we're going to get a z-score for 143. 143 minus x bar, 144, so that's -1, divided by 2.79508. So that is going to give us, let's see, -1 divided by 2.79508. So -0.35777. And then we need a z-score for 145. So we'll do 145 minus 144. So that's +1 divided by 2.79508. So that is going to give us +1 divided by, so positive 0.35777. Okay, so now what we want to do is we've taken these scores and we've normalized them, which means we can put them on our normal curve. There's our nice little normal curve here. Here's our 0. So we have -0.35. It's pretty close to 0. It's right here. And I'm not going to write the whole thing out. -0.358. And then we have the positive, which is about right here. We want to find this area right here. So this guy right here. So that looks to me, it's probably, I don't know, about 30% maybe, but we want to find that exact value. So we can look up these values on the probability or on our z-table, and we can subtract them from each other, or we can use our calculator command, normal CDF. Okay, so to do that, what we would want to do here is we would go second distribution. Our second one here, normal CDF, so we're in between two values. And then we have a lower limit of -0.35777. Let me put the last 7 in, there we go. And then a comma, and then our positive, our upper limit, 0.35. Oh, hold on, my calculator just erased it for some reason. I think my num lock might be on. Let's see. Okay, so we'll go normal CDF, so second distribution, normal CDF. My lower limit, -0.35777. And comma, if I have the 83, if I have the 84, I just go down to upper limit, 0.35777 for the upper limit. And then there on the 84, you would also want to put the mean in and the standard deviation. And since we're on the standard normal curve, that would be a mean of 0 and a standard deviation of 1. And then that gives us our value. We go 4 decimal places, so 0.2795. There we go. So this is right here. That is a probability, 0.2795 for our probability. So I said that was about 30%, pretty close. Okay, so technically about a 28% probability that the sample mean is within 1 month of the mean of all light bulbs produced by the company.